Hydra. It's a unit testing framework for user smart contracts, and there's some nice features. Like you don't need to run your own local node, which helps you in the end to get started testing really fast and quickly. You can read more about it at clearwire.com/Hydra, and I'll give you a practical introduction now. Well, you should see my code now. Okay, so here I have a very simple smart contract that we can test. It's just a message board contract, and there's just 2 actions. I hope the screen size is, or the font size is big enough for everyone to read.
Yeah, it's good.
So, okay, we have like first the sign up action. It takes an account name, like a chain account name and a string name. And then it requires the authorization of this chain account, and then creates a user with this account and this name. So checks if the user doesn't exist yet, and then it creates a new entry in the users table with the account name and the display name. And if the user already exists, it just changes the account's display name. And the second action is the send message action, where you can actually send a message. So it's you send it from to somebody with the message. And again, we require the authorization of the sender of this message. And then we check if both of these accounts exist, the from account and the to account, do some restriction on the message size. And then we send a notification to the recipient and then print out this message here. And how you would usually test it is by downloading EOS.io and then installing it and running a local blockchain, importing keys, setting up a wallet, and creating accounts, and then deploy this contract and then run some tests, run some test actions against it. With Clearwire, you can do install it like this, like it requires npm and node. So you can install it globally, npm install global at clearwire/Hydra. So I already did this part, so I don't need to do it again, but that's how it would work. And then you have the Hydra CLI available. And if you say Hydra init, it asks you what contracts would you like to test. And here's only one, it automatically detects it. So let's select this message board contract. And it also asks you what tables would you like to fill with initial data. That's another nice feature of Hydra that we're not going to use today, but just quickly, Hydra also allows you to load contract table data from actual JSON files. So we would define it in the JSON file and then load this contract data. And then it creates hydra.yaml file here on the left side, which has the configuration. So it's basically just the mapping, what you just selected, a message board with the ABI file and the WebAssembly file, and some options that you don't need at the moment. And then what you also see here is created this boilerplate message board, a test.js file in the test folder. And so whenever you run Hydra init and select a contract, it creates a new boilerplate test for you to quickly get running and to quickly step through it. First, it imports the Hydra environment, the load config in the blockchain. Then it loads the config file from this hydra.yaml file that we just saw. And then here's already the testing boilerplate. So it creates a blockchain with this configuration, creates a tester account. And then before running any tests, it does something once. And what it does is it sets the contract of this tester account to this contract message board that we define in this config file. And what it also does is it updates the authorization of this account to include the EOS code permission. We don't need it for our contract at the moment. Usually you need it when sending inline actions, but our contract doesn't do that. But we included it in the boilerplate because oftentimes you do need it, and then it's good to already have the boilerplate for it. And for each test, it resets the tables. We don't need this at the moment either. And here we can write our first test. Let's say it can send the message. And the way you write the test now is on this test account where the contract was deployed, you can say contract and then the action name. So the action name here would be, let's first create some users by signing them up. So we create 2 users, sign them up, and then send a message from one user to the other. So first we need to create 2 users, and the way to do it is quite simple with Hydra. We say user 1, so it creates a new blockchain account, and this will be the account name. User 2. Then here we can say, check the arguments again, it's called account and name. So it will be account user1.account name, and name, let's just call him user1. Then we also need to provide the permissions that we send it to, because here it's checking for the authorization of the account that's signing up. And this is the same like with any EOS.io permission. So it has the same API. It takes the actor, which is again the first user, and then the permission name will be active here. In Unix, I always get autocomplete when I do any of this stuff. So we sign up the first user. Let's do the same for the second user. User 2. User 2 account name. And now the way we test this action is we check if the table, we check the table data, and we check if the user was inserted into this table. And for that, you can use this get table row scoped action. First, it takes the table name, which is the user in our case, and then the scope, which is the message board. Then it should be equal to user 1, and this name that we said the username should be here, and the second user should also be created, like user 2, and then the way you run it is by simply writing npm test. And notice for the user accounts, we didn't need to set up any private keys, public keys, or wallets or anything. We just say create user, and it's all handled in the back for you. And yet the test passed, like to see if it's actually working. Let's make an error here. Let's say we expected the name to be user 23. Yeah, now it failed, and it says expected user 23, but it was user 2. So this worked well. But let's see, what if you wanted to test an action that doesn't have any effect on a table row, like this send message action that just prints a message? We can also quickly write a test for this one. Then we say contract, instead of the sign up action, we do the send message action. And it's from, to, and message. So from, let's send it from user 1 to user 2. And let the message be hello. And the authorization should be the first user. And now each action or each transaction that we send here returns a transaction trace that we can check. So, and each transaction trace has an action trace with all the actions, because one transaction can consist of multiple actions. In this case, we just want to check the first action trace of this send message action. We say the first one, And .console is how you get the printed statement. And then we expect it to be hello. Just need to change the number of expected insertions to 2 here. And then if we run it again, it fails with expected hello, but received message sent to user 2 hello. It's because we did this prefix here, message sent to. So let's fix that. And then run the test again, and now it should pass. Yeah. And yeah, that's basically all I want to show you for Hydra. As you see, it's very quick to get started writing your tests. And if you want to find more about Hydra, you can check out our website here. Either clivoia.com/Hydra, or you can go to the docs page, docs.clivoia.com, and here's all these things I already just mentioned and showed you, like the quick start guide, some overviews, how to load table data, how to deal with printing and deferred transactions, and also how to integrate it in continuous integration, which works really nice here because you don't need to run a local node. So what I always do is I set up my tests and then let them run whenever I push to a repository, and then the tests run automatically. So that's Hydra, a way to quickly start testing your smart contracts.